target 2.1, master learning objective, I can find the missing side or right triangle by using Pythagorean's theorem. Okay? So this unit is all about right triangles. Okay, so let's first make sure we know what a right triangle is. A right triangle is a triangle that has one right angle. So this is a right triangle here because here is my lovely right angle, right? You have two main types of sides in a right triangle, a leg, and a leg is, you have two of them. So they are the sides adjacent that's next to, right? So adjacent just means it's next to. Okay. So this is a leg, right? It touches the right angle. And this is a leg. Again, it touches that right angle. And our hypotenuse, we have one of those, and it is the side opposite, right, or across from the right angle. So this is our hypotenuse. What Pythagorean's theorem tells us is if I take the two legs and I square them and add them together, that will equal the hypotenuse squared. Okay? We often say that we have side A, side B, and side C, and say A squared plus B squared equals C squared. Okay? Again, you might have heard this before. A lot of times it's like in 8th grade, you go over Pythagorean's theorem. So A squared plus B squared equals C squared, and we can solve then for any of those sides if we have the other two for a right triangle. So looking at example 1, I want to find the missing side of the right triangle. So here, I want to make sure I know where my right angle is, and then I have legs. For my legs, it doesn't matter which one's A and which one's B. So I'm going to say A, B, and then the hypotenuse is across from that right angle, so that's C. So we have A squared plus B squared equals C squared. A and B are 6. And then C is just X. And now I'm solving for X. The first thing we want to do is square the numbers. So I have 6 squared is 36. 4 squared is 16. And then X squared, we'll just say is X squared. Then, if your numbers are on the same side, I just have to add them up. So 36 plus 16 is 50. Equals X squared. And then I want to take the square root. When I take the square root, I need to simplify my radical. With simplifying radicals, I'm looking for a perfect square that divides into 50. Okay, and perfect squares are numbers that come from squaring some integer, some other number. So if I take the square root of 50, I get this decimal. I don't want that. So what we're going to do is, I want to find a number, a number that divides into 50, that is a perfect square, right? So if you think like 1 squared is 1, 2 squared, 4, 3 squared, 9, okay, so on and so forth. But I want to find the largest one. So the one I'm thinking of is 5 squared, right? And 50 divided by that 5 squared, 25, is 2. So that means I can write this 50 as the square root of 25. I want to rewrite that. The square root of 25 times the square root of 2, right? Because 25 times 2 gives me 50. Then the square root of 25 is 5, and then I'm left with square root 2. Okay, so we want to make sure we're simplifying radicals. Simplifying radicals is one of our Khan Academy quizzes for this unit, so make sure you're practicing that. All right, let's look at our next example, B. Here, right, again, we want a squared plus b squared equals c squared. So to figure out where a, b, and c are, well, here's my right angle. A and b are my legs. And again, it doesn't matter which one's which. And c is my hypotenuse. So plugging those in, I have 3 squared plus x squared equals 5 squared. So the first thing I'm going to do is square all my numbers. So I have 3 squared is 9. 5 squared is 25. Now, where here my numbers were on the same side, here my numbers are on opposite sides. So that means I have to do the opposite, right? And we get x squared. 25 minus 9 is 16. And then I take the square root. The square root of x squared is x equals the square root of 16. Now this one I can take the square root of, right? The square root of 16 is just 4. And that is it for that part. All right, let's go ahead, turn the page. Now we have a word problem. The top of the ladder rests against a wall 23 feet above the ground. The base of the ladder is 6 feet away from the wall. What is the length of the ladder? So the top of the ladder rests against a wall. Here's my wall. Here's my ladder that rests against it. It's 23 feet above the ground. Okay. So that's the height. The base, remember the word base means bottom. So the bottom part of the ladder is 6 feet from the wall. So that's this distance here is 6. And it's asking us to find the length of the ladder. Well, my ladder is the thing resting against the wall. So then, right, I'm assuming the wall and the ground make a right angle, so that's my right angle. These are my legs. And this is my hypotenuse. So then we're doing a squared plus b squared equals c squared. So a is 6 squared plus 23 squared equals my x, what I'm solving for, squared. Squaring my numbers, 6 squared is 36. 23 squared is 529. These are on the same side, so I'm just combining them. 36 plus 529 equals 565. Then I'm going to take the square root. And then, can I take the square root of 565? No. So I'm going to look for a number. And perfect squares, I'm thinking like 25, and 25 doesn't go into it. When I divided by 5, I got 113, so I don't think there's going to be any square root that or any perfect square that goes into it. You could keep trying. I could try 36, 49, 64, 81, but eventually these numbers are getting too big to even make sense. So I'm just going to assume, since I've gone through a lot of big numbers, that there is no perfect square that's part of 565 and that it doesn't simplify. All right, then we have the converse of the Pythagorean theorem. The converse states that if a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, so if you don't know if that angle is actually a right angle or not, you can check if you know the lengths of the sides. So this happens a lot in like construction and stuff. It's easier to measure sides than it is to be accurate with how you measure angles. So they'll measure like their sides and then see if it forms this right triangle. So are the following triangles right triangles? So again, I'm going to do a squared plus b squared equals c squared. Your longest side is c. Okay, so whatever the longest or largest number is c. And 3 square root 34 is my largest number here. So that's c, which means this is a and b. So I have 9 squared plus 15 squared equals 3 square root 34 squared. So that looks odd, but we will do that. So 9 squared is 81. 15 squared is 225. And that should equal, if I do 3 times the square root of 34 squared, I square both of these things. So 3 squared is 9, and the square root of 34 squared is just 34. And I'd multiply those together. Or, with parentheses, I can type this whole thing in my calculator. Okay? And square it. We get 306. These things are on the same side, so I'm going to add them. 81 plus 225 is 306. And that does equal 306. So I would say yes. It's a right triangle. Okay, those sides do work out. Our last example here, again, same thing. Our longest side here is C, meaning this is A and B. So when I do A squared plus B squared equals C squared, I have 22 squared plus 14 squared equals 26 squared. 22 squared is 484. Fourteen squared is 196, I know that one. And then 26 squared is 676. So 484 plus 196 is 680. It's the right color. Alright, when I combine these, and then on the other side I have 676. And these are not equal. So while they're close, they are not equal, so no. Not a right triangle. And that is it. Okay, so I will see you guys tomorrow and have a great rest of your day.